Good morning, student. At the first, let us recall what are the things we have learned in previous class. We have seen three properties of rational numbers. When we put that in a summation, we can understand that rational numbers are closed under operations of addition, subtraction and multiplication. Rational numbers are closed under operations of addition, subtraction and multiplication. The operations addition and multiplication are commutative for rational numbers, and second one associative for rational numbers. So when we say that division and subtraction are not commutative for rational numbers and not associative for rational numbers. Let us see another, we can see a first example question. We are going to add these four rational numbers. In 7th standard, we have studied to add two rational numbers, subtract two rational numbers and multiply and divide. Here we are going to use more than two rational numbers. So here if you see that the denominators are different, they are not same. To add rational numbers, we need to make these denominators same. To make this equal, let us find the LCM of these four numbers. For that, we can use the long division method. So we can take the numbers 7, 11, 21 and 22. Let us divide. We can take the very least prime number, which is 7, or we are starting with the 7. It is easy for here, otherwise we have to take many numbers. As a practice, we have to start from the lower number. If you are thinking in that way, you should take 3. So if you take 3, then we have a lesser than 3 a number, which is nothing but 2. So we can take 2 first. 2 is the least prime number. So if we take 2, 7 is not divisible, so we can write as it is. And 11 also not divisible. 21 it is not also divisible. So 22 is divisible by 2 by 11 times. Now we can take the next number, which is 3. 3 goes in 21 3 times. 7 is not divisible, so we can write 7 as it is. 11 is not divisible. Then 21, 3 goes in 21 7 times, and we can take 11. Now this time we can take the next number, which is 7. So 7 goes in 7 one time. 11 is not divisible, so we can write 11 as it is. 7 goes 7 one time. 11 is not divisible. Now we can take the next number, which is nothing but 11. 1 is not divisible. 11 goes in 11 one time. 1 is not divisible, and 11 goes in 11 one time. Now we can take all divisors and find the product. When you find the product, when we multiply 2, 3, 7 and 11, we'll get 462. That is the LCM of 7, 11, 21 and 22. That is 462. This is the common denominator. We should make it. So we are going to change on the first fraction 7 by 1. The denominator we have to change it as 462. For that, it is enough to multiply this denominator by the remaining numbers of this divisors. So that is nothing but 2, 3 and 11. The same thing we can use for the numerator also, 2, 3 and 11. Using that we can multiply the first one. The second one, minus 6 by 11, that you are going to, this time we used other number than 11. 2, 3 and 7. 2, 3 and 7. So numerator also. Plus the next one, minus 8 by 21 into we can, so now this time we have 21 in the sense 3 into 7, 3 7s are 21, so 21 is there. So we can take another numbers nothing 2 and 11 plus next one 5 by 22. So here we have 22 is here, 22, which means 2 into 11 is there. We have to multiply only 3 and 7, so we'll get 3 and 7, which means when you multiply these numbers we'll get 462. Same in the case of all four numbers. So this is the LCM we have to make. This is the equal of this question, which is equal to the question. Now we can multiply, when you multiply the denominator we get 462. Numerators, let us multiply. So which are the numbers we have? See, 3 2s are 6, 6 3s are 18, right? 6 3s are 18 into 11. 18 into 11. So we'll get, it is easy to multiply with 11. First we will write these numbers 1 and 8. 1 and 8. Just add these two numbers, 1 plus 8, 9. So 198. It's very easy to multiply with 11. So 198 plus, now this time the same thing, 462 here, denominator. The numerator we multiply these numbers. So here if you see that 6, here 2 3s are 6. 6 into 6, 36 into 7. So 36 into 7 we want to multiply. 4 says 6 7s are 42, right? Then 4 will carry there. So 3 7s are 21 plus 4. 21 plus 4. Okay, 25. So 252. So here we have sign, negative sign. So it is negative 252. Okay. Plus again here denominator 462. We can multiply the numerators. See, if we multiply 8 into 2, 8 2s are 16. Again 16 into 11. 16 into 11 we can write 1 6 and add these numbers and write. So 176. It is also negative. Plus this one, denominator 462, when you multiply this one, if you have any doubt what I am teaching, you can just verify. Then 5 into 3 into 7. So 5 3s are 15. So 15 into 7. So 7 5s are 35. 3 carry over there. Then we can have 1 7 plus 3 10, 105. Now we have common denominator, that is 462. The numerators 198 negative. See, this is a number negative. So negative, positive into negative. We have a rule, we have studied that positive into negative, that is equal to negative. That rule we apply here. So 252 and negative 176, positive 105. Now we can add positive numbers together. Positive numbers, that is 198. Then we can add 105. 8 plus 5. So 13. 1 will carry over there. So we'll get 10. Again 1 we can carry. So we get here 303. Okay. So which is positive numbers 303 and both negative numbers. When you add two negative numbers, answer also negative. As when we add two positive number, answer is positive, the sum is positive. When you add two negative numbers, the sum is negative. So now we can add these two numbers, that is 252 and 176. When you add this 8, when you add these two, what we get? 12. 1 we can carry over there, we get 428. 428 by 462. Now we can find the difference of it. How do you find 428 minus 303? You can find the difference now. So 5 to 125. So 125 divided by 462. It is a negative number. Now the answer is negative 125 upon 462. This we can take it as method 1, which means we are going to do the same question in another method. Okay, so this time I'm going to write the question again. Here 3 by 7 plus negative 6 upon 11 plus negative 8 upon 21 plus 5 upon 22. Here I'm going to write the first number in its place. I'm not going to write this one now. Instead of that, I'm going to change its place to here as a third one. What is in the third term, I'm going to bring it to the second, like negative 8 by 21. And the next one I'm going to write negative 6 upon 11. So I have changed the positions here. I have interchanged. So interchanging numbers, I have used here a property, that is commutative property. 5 by 22. So what I am used here, the commutative property. Have used here commutative property. Next, so after that, after using commutative property, I'm going to do these two first, and the third and fourth another group. So I'm going to grouping it. 3 by 7 I'm going to write in a group. So negative 8 by 21 and that one group. So already I have used here curvy bracket, that is normal bracket. So I need to use another bracket here. So I want to differentiate. We need difference. We need to so that I'm going to use it here different bracket, that is square bracket I'm going to use. Plus here also I can use a square bracket plus 5 by 22. Okay, this time I didn't use a bracket here because here negative sign is there. That is why we use the brackets to make it separate, that to tell that this is a negative number. And this time if you see that, I'm not going to make the all four denominators same. I'm not going to find the LCM of all four these numbers. Instead of that, we are going to find only first, we are going to take only this group, and we are going to find the LCM of these two numbers. So if you see that, if you notice the 21 here, 21 is the multiple of 7. So obviously the 21 will be the LCM here. How? When you multiply 7 into 3, we get 21. So only this side I'm going to change. So 7, I want this denominator as 21. So I'm going to multiply by 3. So numerator also. I'm not going to change anything here. Negative 8 by 21. It will be same as it is. Plus here also same we are going to follow. Since the 22 is the multiple of 11, I'm going to just change this 11 into 22. For that I'm going to multiply by 2. Same the numerator also. So we get 5 upon 22 also we can write here. This is a multiplication, this is addition. Both are different. Okay, don't be confused with that. So now we can multiply here. So here we get 9 by 21 plus negative 8 by 21. Here minus 12 by 22 plus 5 by 22. Now we can add the denominators here. 20. So not adding, we can write the same common denominator. Now we can write 9 minus 8 plus positive and negative becomes negative, plus this plus sign. Then we can have this denominator 22, then negative 12 plus 5. Now we can have the answer here. 9 minus 1, 9 minus 8 is 1 by 21 plus negative 12 positive 5. So integer addition you have studied in 6th and 7th standard. Teachers repeatedly taught you this how to do it. So we have to subtract the numbers here. 12 minus 5, we get 7, and write the greater number sign divided by 22. Now this time we can do cross multiplication because we have only these two numbers. So we can multiply 1 into 22, 22, and then we have positive into negative sign. 21 into 7, 21 into 7. 1 7 is 7, 2 7s are 14. So we have 147 divided by these two. When you multiply, what we get? We get 462. Now we can subtract these two numbers. 147 minus 22, we get 125. So which is here 147 is a greater number. So greater number sign is negative 125 by 462. The both methods we can compare. So here we have used commutative property. Here we have made a group. So we have used here associative property. When you practice, you can compare both methods. This one, first of all, what are things that we have done? We have found the LCM of all four numbers, and we have changed all four numbers into denominators of 462, and we did so many calculations we have done here. And the second one, we have just used the properties of numbers. So what did you understand from it? Which method do you find easy? Obviously the second one. The second one we used the properties of numbers, that is commutative property and associative property. So this is the use of properties. The properties of number makes us to do the calculations easily. അപ്പോൾ കാൽക്കുലേഷൻ എളുപ്പമാക്കാനാണ് നമ്പേഴ്സിൻ്റെ പ്രോപ്പർട്ടീസ് നമുക്ക് ഹെൽപ്പ് ചെയ്യുന്നത്. So the properties helps us to do the problems easily. Next, let us do this question. I'm going to use an first one method. Without the properties, and the next one with the properties we are going to do it. Here the first I am going to take the numbers minus 4 upon 5 and 3 upon 7 into 15 upon 16 into minus 14 upon 9. I'm going to multiply these two numbers, negative 4 into 3 by 4 into 5, and these two numbers 15 into negative 14 by 16 into 9. Now for this one, here we can simplify these two numbers using 3 table. In 9, 3 goes in 3 times. In 15, 3 5s are 15. Okay, same way 4 table we can reduce these two numbers. Or sorry, we can use a 2 table here. 4 table 14 can't. We can't do it. So 2 tables 7 times. Here 4 we can use a 2 table 8 times we can do it. So here we can multiply these two numbers. So negative 12 by 35 into these two we can multiply. So 35. So we have here negative sign. So negative 35 by we have 24. Okay. Now we can cancel these two numbers. Okay, these two numbers. So by 35 one time it goes, here also one time goes. So we have here negative into negative, positive 12 by 1 into 24, 24. We get here so 1 by 2. Okay, so 1 by 2 is the answer. The second method we can do it here. So method 2, the same question we can write as negative 4 by 5 into 3 upon 7 into 15 upon 16 into negative 14 upon 9, which is equal to. Now I'm going to interchange or exchange the numbers here, changing the place. So that law is commutative property. How? I'm going to write the first fraction, rational number, my negative 4 upon 5. Then I'm going to write 15 upon 16. I'm going to write it into. Then I'll write this 3 upon 7 into negative 14 upon 9. Why I did like this? If you notice that 4 and 16 are in the same table, and 3 and 9 are in the same table, and also these two numbers also 5 and 15 same table, 2 and 7 same table. So I used here which property? Commutative property. So commutative property have used here, and we can group these numbers here using associativity. Now this we can use 4 table goes 16, 4 4s are 16, and this we can use it 5 table goes in 3 times, and here these we can use it 3 table goes 3 times, goes 1 and 2, and these we can use it 7 table and goes 1 time. Here in 14, 7 goes in 2 times. Okay, so which are the tables we used here? We used here 4 table here. To simplify these two numbers we used a 5 table, and simplify these two numbers we used 3 table. Here we used here as well which table? The 7 times table. So now we can multiply these two numbers. Now this one 1 into 3, so negative 3 by 4 into here 1 into negative 2, negative 2 by 3. So when you multiply these, we'll get positive 6 by 12, which is equal to, when you simplify these two by 6 table, we'll get 1 by 2. So both are same, but we used a different methods. Here we used a two numbers properties. One is commutative property, changing numbers, and a grouping that we used here, associative property. So I think the second one is very easy one to do it when you use the properties. So that's the difference. The properties makes the problems easy. So let us look at another one. Let us do some addition here. When we add 2 with 0, we get the answer as 2, which is same as 0 plus 2. The answer same. What is the result of negative 2 plus 0? It is negative 2. It is same as 0 plus negative 2. When you do it, the answer is negative 2. What is the result of this one? Negative 2 upon 7, the rational number. When you add it to 0, the answer is same as negative 2 upon 7. When you do 0 plus negative 2 upon 7 also, both having the answer negative 2 upon 7. From this one we can understand that the sum is same as the number we are adding with the 0. The sum is same as the number. The sum is same as the number which we are adding with the 0. This in the case of whole number, integers and rational numbers, because the sum is identical to the number which we are adding. That is why we say the 0 as the identity. Since we are doing addition here, we are saying that 0 is a additive identity. 0 is called as the additive identity. Why it is called as additive identity? Because the sum is identical to the number which we are adding. So we can say that 0 is the additive identity for rational numbers, and also the 0, it is also the additive identity for integers and whole numbers. That we have seen that here the examples of it. This is an example for a whole number, here's integers. Now this one, it is rational number which we are learning. Now let us look at these multiplications. When we multiply 5 with 1, 5 into 1, we know that answer is 5, which is same as the 1 into 5. And look at this multiplication. So negative 2 upon 7, when you multiply with 7 with 1, we get the same answer, that is negative 2 upon 7, which is same as when you multiply 1 with the negative 2 upon 7. The answer is same. What is the case of this one? 3 upon 8, when you multiply with 1, we get answer the same as 3 upon 8, which is same as when you multiply 1 into 3 upon 8. Okay, so when you multiply a number with 1, the product is same or it is identical to the number. The product is identical to the number. Identical means they are same. If the product and the number which is same, it is only because when you are multiplying with the 1. So 1 is, here we are saying, the multiplicative identity for rational numbers. It is also the multiplicative identity for integers and whole numbers. So here we have taken a whole number, or we can take an integer also. When you multiply integer with 1, we get the answer as the same. The product is identical to the number. So 0 is called additive identity, and 1 is called multiplicative identity for rational numbers. Let us answer these questions. What is the negative of 1? What is the negative of 1? The answer is, it is negative 1. Negative of 1 is negative 1. So what will be the answer of what is the negative of minus 1 or negative 1? So negative of negative 1 is positive. So negative into negative becomes positive here. So negative of negative 1 is positive 1. Since when we add a positive 1 and negative 1, we get 0. In both cases, we are getting 0. Okay. Let us look at these numbers. This is for natural numbers or integers. And if you take here the rational numbers, what is the negative of 2 by 3? It is negative 2 by 3. When we add 2 by 3 and negative 2 by 3, we get 0. What is the negative of negative 4 by 3? It is positive negative 4 upon 7. Here also positive 4 upon 7. Since we can say that negative 4 upon 7 plus negative 4 upon 7 positive. So negative 4 upon 7 plus positive 4 upon 7, which is equal to 0. So here negative is also called as a additive inverse. Negative, or we say it is a additive inverse. Sometimes we can ask the question as, what is the additive inverse of negative 4 by 7? So it is positive 4 by 7. Children, look at here. When you multiply 4 upon 3 with 3 upon 4, we get 12 by 12, which is equal to 1. When you observe this, see here which number satisfies the multiplication so that product is equal to 1. So the number is 21 upon 8. So here the 21 upon 8, we say the reciprocal or inverse of 8 upon 21, so that it gives a product as 1. So what will be the inverse or a multiplicative inverse or a reciprocal of negative 5 upon 7, which gives the product as 1? The answer is 7 upon negative 5. So we can say that multiplicative inverse or reciprocal both are equal. Okay, when we say reciprocal, it is also that multiplicative inverse. So if I ask you the question, what is the reciprocal of negative 4 upon 9? So we say the answer, it is 9 upon negative 4. Okay, that's the answer. If you notice that these two numbers are positive, when you multiply, you'll get positive 1. We should get the answer as positive 1. So that if you see that when you multiply two negative numbers, we get a positive one. Negative, negative, positive. So that here the answer of this negative 4 upon 9, the reciprocal of negative 4 upon 9 is 4 upon negative 4. Both numbers are negative. Next, we are going to multiply these expressions separately. Let us see what happens the values. So now this side, what is on the left side, we are going to take it. We are going to do addition of the things which is in the inside. Okay, inside the bracket, inside the curly bracket. So negative 3 by 4 into, now here when you add it, here unlike fractions, since it is unlike, we have to make it a like. So the denominator here it is 3. So the if you see here 6 is there. So we have to make it here both we can make it as 6 as a common denominator, since 3 is the multiple of 6. So we can change the 2 by 3, the denominator we can change it to 6. So we have to multiply by 2. Numerator also same number we have to multiply, and we have negative 5 by 6 here. So now negative 3 by 4 into, here we can multiply these two numbers, 4 divided by 6 plus a negative 5 by 6 we have. So we have 3 upon 4 into these two. Now we can add it. When you add it, 4 plus negative 5 by we have 6. So negative 3 upon 4 into here we know that negative 5 is greater, so sign we can write negative number, and then we can 5 minus 4 we can write 4 by upon, so negative 1 upon 6. Now these two we can multiply now. So instead of multiplying, we can simplify here. This bracket also it is treated as a usual one. So the 3 goes in 3 one time, in 6 it goes in 2 times. So now we can multiply here negative 1. This is negative 1 into negative 1, positive 1 into 1, 1. And here 4 into 2 we have 8. So answer is 1 by 8. Let us see what is the answer of this side. Okay, now we are going to do this one. For this one we can take first, let us write this one, negative 3 by 4 into 2 by 3 plus negative 3 by 4 into negative 5 by 6. Now these two we can cancel. So by 2 table goes 1 time, here it goes 2 times, and then 3 goes in 3 1 time, this also goes. So these two we can cancel directly. Now here also here plus is there. What is in the bracket, we do it first. We have completed this bracket, then we go to the second. Now here these two goes in 3 table 1 time, 6 goes in 2 times. Okay, these two we cannot cancel. What is the remaining we have? We can multiply negative 1 into 1, we have negative 1 by 1 and 2 into 1, we have 2, plus here we can do it, negative 1 into 5 we have positive, negative into negative, positive. Remember, negative into negative, which is positive. So we have positive 5 by 4 2s are 8. Okay, 4 2s are 8. Now this one, when you see that the denominator is not equal, so we can make this as 8, since 2 is the 8 is the multiple of 2. So negative 1 by 2, when you multiply 2, when you multiply 4 we get 8. So numerator also we multiply with the same number. Okay, these two we have to multiply, plus 5 by 8. Now when you multiply this one, we get a negative 4 by 8. Okay, negative 4 by 8 plus 5 by 8. Now we have common denominator here, negative 4 plus 5. We get the answer as, so here positive 1 by 8. Look at these, both the answers are same, right? So we can say that this and this expressions are equal. So here what we have done is, what is the difference here? This multiplication here is distributed over addition. So this property we call it as distributive property or distributivity. So distributivity of multiplication over addition for rational numbers that we have done here. So this law is called as distributive law or distributive property. What is distributed here? Here the multiplication negative 3 by 4 is distributed to 2 by 3 and distributed to 5 by 6. So this multiplication is given to 2 by 3. It is given to negative 5 by 6. Okay, it is shared. Distributivity means sharing the multiplication. Okay, distribute. Sometimes teachers ask us to give notebooks, distribute to others. Distribute means give it to everyone. So that is called distribute. Distributing chocolates, we say sometimes. Distributing things. So here multiplication is distributed over addition. So here addition is there. So over addition is distributed. So this is called as distributive law. So when you use, instead of these three numbers, if you use alphabets, if you can use alphabets A into B plus C, A into B plus C, which is equal to, you can say here multiplication is distributed. So A into B plus, same way we can say A into C, A into B plus A into C. This is the same case for subtraction also. So we can say A into B minus C is equal to A into B minus A into C. So ഇവിടെ letters use ചെയ്തിട്ടുണ്ട്. അതിൻ്റെ പകരം ഇവിടെ നമ്മൾ we used alphabets. So law says that here multiplication is distributed. Now let us do this example 5. We should find the answer. So the question is find the solution, which means after doing or addition, subtraction, multiplication, everything, find the final number. So here we have taken the expression given here. The first thing we are going to change is we have three groups or three terms we can take. This is the first term, this is second, and this is the third. These two we are going to interchange using commutative property. So negative 3 upon 7, 2 upon 5 into negative 3 upon 7, and we can write negative 3 upon 7 into 3 upon 5 minus negative 1 upon 14. After this, we again rewrite this one as like this: 2 upon 5 into negative 3 upon 7. Here we are in positive sign. This we can write as negative 3. So positive into negative, we get negative again. We are just changing to get these two are same, look like similar or same. Then into 3 upon 5 minus 1 upon 14, which is equal to, now we can make these two as a group. Okay, this one group and this is another group. So this grouping is we are doing using the associativity and grouping these two as together. So we used here usually which commutativity. Commutative law. And here now what we are going to do is we are going to take the so only one property we have used here. If you see these two, negative 3 upon 7 is common for both, so that we can take it as outside into, that's 3 upon 7 into this one, what is remaining, that you can write inside this bracket, 2 upon 5 plus 3 upon 5. This we did using the distributivity. Negative 14 remaining is there. So here we used the distributivity. We use the distributivity here. So distributive law, how we used here, if A into B, what is that? A into B plus A into C, if it is there, we can write as A into B plus C. That model we have here. Here instead of A we have 2 upon 5, instead of B 2 upon, no sorry, we have a 3 upon negative 3 upon 7 is the A value. Both are same value, right? And instead of B we have 2 upon 5 and 3 upon 5. So that we can write as A into B plus C. So that A we have taken as common outside. A is taken common outside. So like that. Now these two we can add it. Negative 3 upon 7 into, like terms are there. So no cross multiplication needed. ഇവിടെ cross multiplication നമുക്ക് ആവശ്യമില്ല. കാരണം denominator same number ആണ്. Denominator same number ഉള്ളപ്പോൾ നെഗറ്റീവ് നമ്മൾ cross multiplication ചെയ്യേണ്ട ആവശ്യമില്ല. So just directly we can add it. We get answer as 5 upon 5. 2 plus 3, 5 upon 5. Negative 1 by 14 or 1 upon 14. Now these two we can multiply, or here this is 5 upon 5 is 1. Negative 3 by 7 or negative 3 upon 7 into 1 minus 1 upon 14, which is equal to, rendu multiply the additive identity and multiplicative identity. So we'll get the same answer, 3 upon negative 3 upon 7 minus 1 upon 14. Now here different denominators we have. To make it equal, we can make it we can take LCM as 14. So how 14 means 14, if you see this 7 and 14 is the multiple of 7. So we can make it easily 14 here by doing multiplying this 7 by 2, and the same thing we have to multiply with the numerator. Negative 1 by 14 here we have. So these two, when you multiply this one, so we get the answer as negative 5, 2 3s are 6. Okay, negative 6, we have 6 here, 6 by 14, 6 by 14, negative we have 1 by 14. Okay, 1 by 14, which is equal to the answer of this one we can write here. So here common denominator and negative 6 and negative 1 we can write here. Both are negative, both negative, the answer is negative 7. Put the negative sign and write the numbers you add and write. This is the integers rule. So negative 7 upon 14, which is equal to, we can simplify these two by 7 table. It goes in one time, 7 goes in 7 one time, 7 goes in 14 two times. The answer is negative 1 by 2. This is the final answer. Now let us see what are the things we learned in this class. As a summary, the rational number 0 is the additive identity for rational numbers. The rational number 1 is the multiplicative identity for rational numbers. The additive inverse of a rational number A by B or A upon B is negative A upon B, and vice versa. The reciprocal or a multiplicative inverse of a rational number A by B or A upon B is C upon D. If when we multiply these two numbers we get 1. Distributivity of rational numbers. For all rational numbers, if you take three numbers a, b, c, n, we can say a into b plus c is equal to a into b plus a into c. And for subtraction, a into b minus c is equal to a into b minus a into c.